Hello again, my math friends. This is Mrs. Schlecht, and in this video, we're going to look at equivalent ratios. All right, my friends, so you know there's a few materials that you need in order to be successful for this activity. First, you need that Envision textbook. That's the one with that little robot guy on the front. Second, you're going to need your math notebook. Third, you're going to need a pencil. And fourth, last but never, ever least, you're going to need that positive math attitude. All right, my friends, so the two lessons that we're going to go over this week really try to get you to understand the relationships that different proportions have. We can also think about it as looking for different patterns and different equations that we can use to represent those patterns. But before we get way too ahead of ourselves, let's just focus on lesson 2-3. So lesson 2-3, it really gets us to look for equivalent ratios. Do you remember what that word equivalent means?
It means equal, Mrs. Schlecht.
Yeah, you're right. Equivalent means equal. So what we're doing is we're going to be looking at a series of different ratios, and we're trying to see if they are all equivalent. So before we get going, please check out the key concepts page for this lesson, which is on page 104. All right, my friends, let's get going. That first problem we're going to look at together is on page 104, and it's number 6. All right, again, my friends, when we're looking for proportions, another word that I like to think about is a pattern. Is there a pattern that helps us get from one side of our table to the other side of the table? And not only is there a pattern, but is there a consistent pattern? Is there a pattern that works here and here and here? And that way I can then use that pattern to help predict where I'm going to go in the future, right? So here's how we're going to do this. You ready? Are you ready? Are you ready?
Are you ready?
Of course you're ready. It's math time. Whoop, whoop. All right, so again, page 104, number 6. And this question, my friends, is comparing the hours that I'm selling tickets with the number of tickets that I have sold. And you'll notice it's kind of a two-parter question, right? The first part is just asking us, hey, is this even proportional? Is there a proportional relationship between the hours and the ticket sales? Okay, so that's part 1, right? Part 2, my friends, is then, hey, if it is proportional, if you do find a pattern that we're able to use to represent all of these different relationships, then it's asking us to build upon that pattern, to use that pattern to make predictions about some missing information, right? So it will tell us, hey, in 8 hours, if this pattern continues, then how many tickets am I selling in 8 hours, right? So 2 parts, right? First, we got to figure out, is this even proportional? And then second, if it is proportional, can we then use that to help us predict how many tickets we would sell in 8 hours? So first, my friends, let's see if this is all proportional. All right, so what I did, my friends, was I took our original table. Remember, we have hours, and then we have number of ticket sales. And what I did is I wrote that as a ratio. So I now have 3 separate ratios. And the ratio I made was the number of tickets sold over the hours, the time that I spent selling these tickets. All right, my friends. So this first part, I sold 240 tickets in 3 hours. Second, I sold 400 tickets in 5 hours. And lastly, I sold 720 tickets in 9 hours. So now, my friends, I have 3 different ratios, but they don't look the same, right? How can I compare them if they don't really look the same? So what I'm going to do next is I'm going to simplify all of these ratios. So I'm going to try to pull out that greatest common factor, my friends, so I can simplify these ratios so I can write it as the simplest format that I possibly can. Ta-da! Look at this. Look how super nice and easy peasy this was. So my friends, I noticed that when I took the number of tickets that I sold and I divided it by the amount, the time, the hours that I was actually selling tickets, oh my goodness, look at this. 80 tickets an hour, 80 tickets an hour, 80 tickets an hour. My friends, that means that we found a pattern, which means this is all a proportional relationship, right? Check that out. We got some equivalent ratios here. I know they look a little bit different, right? But when we simplify them using that greatest common factor, my friend, we are all able to simplify it to 80 tickets per hour. So our first step for that problem was to find out if it's proportional. And yeah, it's totally proportional. The second part, if you remember, was it gave us a mystery amount, right? It said, okay, If this pattern continues, if I'm selling 80 tickets per hour and I'm selling for 8 hours, now it wants to know, here's the mystery piece, right? Well, then how many tickets am I going to sell? So let's think. If I have 80 tickets per hour and I'm selling it for 8 hours, that sounds like a multiplication problem. So how many tickets would you finally sell in 8 hours?
You are so smart, and you know that 8 times 8 is 64, but you have that 0, which is a power of 10. So what's 80 times 8? That's gonna be 640. Good job, 640 tickets that we will sell in 8 hours. So in that first problem, that was so nice, right? It was, in fact, a proportional relationship. Whoop, whoop. But let's see, what would a problem look like if it is not a proportional relationship, okay? Kind of a spoiler alert, sorry, my friends, but let's just play around with it. Let's see what that looks like. So please, let's check out page 105 and number 10.
Check out number 10. All right, my friends. So all I do is I just copied the same table that's in your book on page 105 for number 10. I just copied that on the board. And it gives us a table, and it gives us two different components of that table, right? We got our X factor, which is all the way across the top, 4, 5, 6, and 10. And then we have our Y, which is our second row of our table, 64, 125, 216, and 1,000. You'll notice that Mrs. Schlecht also wrote down another box for my ratios. So here's what I'm going to do first, my friends. I'm just going to write each of these four different sections of my table. I'm going to write it as a ratio because then we can compare the ratios, right? So what I'm going to do is I'm going to write my ratios as Y over X. I got my friends. So again, I wrote these as a ratio for Y over X. So now I have 64 over 4, 125 over 5, 216 over 6, and then 1,000 over 10. My friends, I'm now going to simplify the ratio so that we can look to see if they're equivalent or not. Check it out. Yeah, look at this, my friends. So when I took that ratio and then I simplified each of my ratios, so I had 64 over 6, I got 16. When I simplified this ratio of 125 over 5, I got 25. When I simplified this ratio of 216 over 6, I got 36. And then when I simplified 1,000 over 10, I got 100. So my friends, you're brilliant. You should know this. I'm pretty sure 16, 25, 36, and 100, not the same numbers, right? Because they're not. So what that means is, unfortunately, problem number 10, you are not Nope, you are not proportional. So did you notice that there's also a second part to number 10? It asks us first to find out if this is proportional, and we discovered it is not proportional because, again, my friends, 16, 25, 36, and 100, not the same numbers, right? If they were proportional, then it would be all the same number all across, but it's not proportional, not proportional. So the second part of number 10, my friends, is asking us, hey, if it is proportional, then can you make a prediction that if 11 is my X, then what would my Y be? But again, my friends, we can't make that prediction. We can't make that prediction. And why not? Because this is not a proportional relationship, people, right? I can't just plug in X and make up any old random number, right? Because, my friends, look, we're not really following that pattern, right? There's really not one to speak of. So again, problem number 10, sorry, buddy, not proportional. And therefore, we cannot make any predictions about what 11 would be with a Y. And so that was just a quick run through of lesson 2-3, which again helps us look for those equivalent ratios. Equivalent meaning equal, my friends. If you have any other questions after watching this video, please let me know.